We're talking here with Len Bosack at OFC, and Len, I wanted to talk to you about this goal you had set for your company years ago of doing a terabit per wavelength. Why did you set such a high goal so long ago?
Greg, when you build a system that you're going to have in the ground, you'd like to be able to survive multiple generations of technology. And so we selected a terabit because, based on fundamental physical parameters, it appeared feasible. And not in a 100-year time frame, but in a 20-year time frame. So 2020 for terabit per carrier. And we wanted to give our customers the ability to build a system and to go from generation to generation of technology without fundamental change in their outside plant.
Okay, how long ago was this?
2001.
2000, and when you told people about a terabit in 2001, what did they do?
Blank stare.
When you tell them now, what do they do?
Oh, why can't you do it sooner?
So how has this manifested itself since 2001? The equipment you've got today, have you pretty much set that goal or achieved that goal of having that the transparency generation to generation?
We think that we have, on a fundamental physical basis, the ability to get there. We've paid an enormous amount of attention to linearity and noise in our amplifier chains. We have, for example, in our laboratories, 1,700 kilometer systems that actually run and work and are delivering results that we can play with in terms of experiment. We started with 1 gig, we moved to 10 gig, and yes, the dispersion sensitivity goes as the square of the symbol rate. Sorry about all that technical gobbledygook, and we think we're going to be able to go to either standard or non-standard, and it doesn't matter to us, 100 gig. And further, we are sure that with appropriately high bit density modulation, which we knew in 2001 would be required to be able to go to a terabit per carrier.
Okay. Oh, I'll ask you this, and you can get into some of the technical gobbledygook if you would. What for you is the next important step you have to get through, the next barrier if you want to get towards terabit?
Well, there's 2 problems. One is the line modulation format. We know that spectral bit density has to go up, and reasonably sure that it's going to have to be some form of what's technically called quadrature amplitude modulation. In the short run, the 100 gig standards, there's a lot of interface uncertainty right now for the customers, so perhaps that's not one of the better achievements in the current generation of 100 gig, but how do you get past that for customers? We think we can do it on the line side, but part of the challenge right now is the process having as its goal a smooth customer transition from 100 to 250, 400, what have you, to a terabit. And I do pray that our good standards committee members are thinking about this.
Okay, yeah, that's the message I'm getting, is that you want to set everything up for that easy transition as you go from one generation to the next.
Further, you have more than one generation active at a time. When 100 gig router ports came out, well, I believe you gave more than $1 million per. Now they're pleasantly less expensive than that. When several 100 gig router ports come out, once again, I expect them to be the $1 million router port, and then prices will fall. So you know that not everyone is going to go too sweet to the new technology. So you have to at least have 2 generations in coexistence, and better 3. So we're well aware that we'd like to make our system easy and reliable for our customers. Things that you know they have today will have to continue to work for a good while. They have a return to get on their investment.
Okay, great. Well, Len, thanks very much.
All right, Craig, here we are, another OFC.